Okay, so hello everyone. In this video, we will be solving the question number 1260, which is shift to the grid. It is marked easy. The question is easy to understand and it is easy to implement as well. We will be solving it using two approaches. One will be in n cube and the other one will be in n square. So let's first understand the question, what is it about, and how to approach the question. Okay, so let's start. We are given a 2D grid of size m cross n, okay, and an integer k. We need to perform the operation of shifting the grid k times, and in one shift operation, these are the three conditions. If an element is at grid I comma j, we need to move it to the grid I j plus 1. If element is at grid I n minus 1, which is at the last column, we need to move it to grid I plus 1 0, which is the next row and the zeroth column. If the element is at grid m minus 1 n minus 1, which is at the last position of the entire grid, we need to move it to grid 0 comma 0, which is the first position. And we need to return to the grid after applying the shift k times. Okay, so we will be given an m cross n. M is the number of rows and n is the number of columns. We are given an m cross n in a grid and we need to perform the shift operation k times, and in each shift operation the number at the current element position is shifted to the next position. You can see it here. One was here and after shifting it came to this position on the right side. If the element is at grid I n minus 1, here n is 3, and if element is at grid I n minus 1, which is at the last position of a particular row, it will be shifted to new row and next first position, which is grid I plus 1 and 0. If the element is at grid m minus 1 and n minus 1, which is here, we shift it to first position, which is grid 0 comma 0 0 comma 0. So how will we approach this question? So you might have guessed it. If a element is not in the last, like in the last column, if it is not in the last column, we just simply shift it to the next position, that is to the right, which is I is same, and j plus 1 0 become 1. If if it is at the last column, we check that whether is it at the last row. If it is not in the last row, we simply shift it to the next row and in the first position. Okay, if it is at the last row and the last column, we shift it to the first row and the first column. As simple. So what was our approach? Is it in the last column? Yes, it is. So is it in the last row? Okay, yes. Then we move it to 0 comma 0, which is this case 9. 9 is in the last column and in the last row. We shift it to 0 comma 0. It is in the last column, but it is not in the last row. Ah, it is in the last column, but not in the last row. So what we do is I plus 1 and 0. 3. 3 was at 0 comma 2. it is in the last column, so it was shifted to here, which is I plus 1. I was 0 and now it is 1. It is not in the last column, so what we do is next position, which is I plus 1 and j plus 1. Okay, so what should be our approach? That it moves to the next position and require minimal space. So why don't we keep a track of if we are at this position as of now? As of now, we are at this position. So what we'll do is we will use two extra variables, which is cur and next. So what we'll do first, we will store what is the next element. We will store the next element, and then we'll replace this position with this one. So if we do that, the next element is also not lost. We keep a track of that as well. And what we'll do is update current with next. Okay, so let's understand it here. We will store next with next element and replace next position with current, and then let's make it easy. And then what we'll do is update cur, which is okay. So what we have done is so here it was 1, here it was 1, and here it was 2. So while we were iterating this, we stored these two somewhere, and after updating these two with this one, what we did was we updated current element with 2 so that we do not lose the track of the number which has been replaced. So after replacement it would be 1 1 3, but we want to replace 3 with 2 also, so we update the current with 2, and then we replace 3 with next, and as a subsequently we do that operation. Let's first understand like through an example, like solving it using this n cube. If you have any doubt, we will surely solve it. We will first take number of rows and columns. So m equals to grid dot size and n equals to grid 0 dot size. Okay. Now what we will do is we will do the shifting operation k times. Okay. And what we have decided here is that we will use two variables, which is current and next. Current will be at the I and j, and next will pointing to the next position through which we need to replace it. Just a second. So from starting, we'll start the replacement from start. So current will be the grid 0 comma 0, and next we don't. Why we don't know? Because we don't know whether it is the next row's first element or the number just on the right, or if the element is at the last position, so the first element. So we will calculate the next position and then calculate the next element, its values. So what we will check is if like we need to iterate all the elements, right? So for int I equals to 0, I less than m. M is the number of rows. Yep. For int j equals to 0, j less than n, j plus plus. This is number of column. Element is at grid ij. So what we will check is it at the last column? If j double equals to n minus 1, it means that it is currently at the last column. Now what we will check is if I double equals to m minus 1, which is last row. So it is at the last column, last row. So let's create one variable int next row and next column. So if that's the case, that is a number is present in the last row and the last column, so next row should be 0 and the next column should be also 0. Next row equals to 0, next column equals to 0. Okay, if that's not the case, it means that a number is in the last column. A number is in the last column, but it is not in the last row. It means that it could be 3 or it could be 6. So the next row will simply be I plus 1 and next call will be 0. So for these elements, the next row was the I plus 1 and the column was 0. Okay, and yeah, if it is not in the last column, if it is not in the last column, it is before it, somewhere here. So it is safe to just shift it to the right. So next row will be I in the same row, and next column will be j plus 1. Same row, right column. Okay, if it is in the last column, we check if it is in the last row. If that's the case, 0 comma 0. If it is in the last column but not the last row, it will be I plus 1 comma 0, else I j plus 1. But before we lose the track of the next element, we'll update the next equals to grid next row next call. Do not lose track of next element. Replace next was with cur. So grid next row next call equals to current, and we will update cur with next. Curr equals to next. Okay, so it will happen over all the elements, and then we will return grid. I guess this should work. Okay, this is accepted, but here is O of k, here it is O of n, and here it is O of n, which is 3 times, which is O of k star n. Since the constraints are not very big, it is acceptable. but we can see this, it is of n power q. Okay, we need to optimize this. So how will we do? Let's first submit it to check that the given solution is correct. Okay, now what I have thought is, here it was 0 1 2 n equals to 3, m equals to 3. So we can say that there were total 9 elements, and we can position each, like give each uh, what you can say element one position, because you can see that, suppose 0 1 0 1 2. We can say that here it is at position 0, it is at position 1, position 3, 2, position 3, position 4, position 5. If we want to just update it, like here it is at position 4, and after k shifts it should be at position 4 plus k. Here it is at position 0, and k is equals to 1. So 0 plus 1 is 1, so it should be at position 1 after. So here it is at position 1. We got that. Here it is at position 5 after k shift. Suppose the k was 2, then if k was 2, 5 should come, 6 should come here, and then it will come here. Okay, so 5 to plus 2, which is 7, so it will be at 7. So we are getting a hint. After k shift, its position should be current plus k. But what it is at the last position? If it is at last, just for k equals to 1, it should come to 0. How we will do that? If it was 8, then after 1, it should be 9. But it is at position 0. So we can say that it got moduloed by 9. Suppose 7 and k was 2, then it should be 9. So here, if 8 was the number, it had to be shifted twice. So it would come here, and then for k equals to 2, it will go here. Okay, so for that also it becomes 0. So we can consider that what we will do is current plus k, and then modulo by m cross n, which is the total number of elements. Dot le equals to m star n. If it was 0, and then we need to do the addition by shift by 9, 0 plus 9 modulo 9 will be 0. But what about k was 13? 0 plus 13 by 9 modulo 9 will be 4. So it should be here, because after 9 operations it will go to each end 1 2 3 4 5 6 7, 1 2 3 4 5 6 7 8 9 10 11 12 and 13. So is this equation correct? Correct. Current plus k modulo m star n. Okay, it is correct. We also found out that it will come at position x. For example, m equals to 3, n equals to 3, and x equals to 4. We have found out that after k equals to 13, it will come to here, position number 4. But how will we find out that it is in the first row and the first column? So what we'll do is, we have found in the position 4. So what we'll try to find is how many number of rows do we need to skip first. Like how many rows can be deducted. Like 4, 0, 1, 2, 3. One row contains three three elements. One row contains three elements. So how many such rows can be skipped? So what we will do is mm, x modulo number of LE in in row, which is nothing but number of columns. Are you getting my point? Like mm, suppose 0, 1, 2, 3, 4. In this case 5, 6, 7, 8. There are two columns, four columns, and two rows. If we want to find 4, so what we will do is 4 modulo 4 divide. We will not find modulo, but rather divide. 4 divided by the number of columns. 4 by 4, which is equals to 1. So this will be the first row. Likewise, what we have found is we 4 divided by 3 to 4 divided by 3, which is 1. So it will lie in the first row. But how will we find out that after that how much, what you can say, columns do we need to skip? Are you guys understanding that? Okay. If if here is 4, we found out that 4 divided by 3, which is the number of columns. 4 divided by 3 is 1. It lies in the first row, or we can skip one row. One whole row is to be eliminated, and some portion of a new one is still remaining. Are you guys clear with it? To let me know, because even this is a bit trickier. For suppose n equals to 3. So 3 divided by 3, which is 1. So the one row is to be skipped. One row is to be skipped, or you can consider that the answer that we get is the number of the row in which it lies. Okay? Here it is 3, here it is 4, but we found out that we need to find the column as well. We need to find the column as well. So don't you think there is one pattern that if it is 4 and the number of rows is 3, 4 is lying on 1. If the number is 3 and the number of columns is also 3, it is lying on 0. If the number is 4, columns are 4, then it is lying at what you can say, 0th column. So you can say that 4 4 modulo false. Here it will be 4, 4. This is 0. This is the column. Okay, we found out that this this particular this particular number after k will be at current plus k position, and then we need to modulo it by m modulo m multiplication n. So we'll get the final position. After we get the final position x, we divide it by the number of columns to get the row in which it lies. And for the column number, we just do the modulo by columns. Okay, but 1 is to be shifted here, 2 is to be shifted here. We are not doing this in place because if we do 1 by 5, then we shifted 1 to 5. But our next operation will be on 2, and this 5 will be lost. So what I'm thinking is we will create one extra array grid so that we can do the replacement or the addition without any of the drama or like storing the next element or the replacing one. So let's do that implement as well. I guess explanation was not apt, but if you have any doubt or not able to understand, do let me know. This is a new grid of m rows and n columns. Okay, now we will iterate each element for int I equals to 0, I less than m, I plus plus, which is the row, for int j equals to 0, j less than n, j plus plus, which is column. Now you guys also be thinking that how will we get the current? So current will be nothing but m, the number of rows, m cross j, m cross n, I cross n plus j. This row 0 1 2 for 0, 0 into 0 plus 0, which is 0, 0 into 0 into 3 plus 0, which is 0, 0 into 3 plus 1, which is 1, 0 into 3 plus 2, which is 2, 1 into 3 plus 0 3, 1 into 3 plus 1 0. So I multiply by n plus j, I multiply by n plus j, int new pose will be current plus k, and int final pose will be int pose modulo m star n. Okay, now we will need to find the row number, which is row which is equals to final pose divided by number of elements in that row, which is nothing but the column, and the column is denoted by n. Int col equals to final pose modulo n. Read row col equals to grid I j. So what we have done is, for each element we have found its current position, which is nothing but I cross n plus j. After finding current position, we have added k, which is the number of times the shift operation should be performed. After k operations, its new position would be current plus k. But what about this one, this last element? It will go out of the box, out of the grid. So what we do is, after finding the current and final position, new position, we do its modulus by the total number of elements, so that it remains within the positions of this grid. But after we have found out the position, we also want the row in which it lies and the column it lies. So what we do is, we find the number of rows to be skipped, which is nothing but the current position divided by the number of elements each row consists. Each row consists of n elements, which is but number of columns. So final position divided by n, it gives us number of rows to be skipped, and here it is zero based. We can say that the row in which it lies. After we have found row, we need to find the column, but you can also find a pattern that in the zero all the multiples of n, or in the one, multiples of n plus j, multiples of n plus j. So what we do is, j is nothing but the final position modulo n is nothing but a column number. Okay, see, 100%. I'll tell you why. Because we are iterating the loop only, nested loop, which is O of n, O of n. So final time complexity will be O of n star n, which is O of n square. Space will be, we are creating extra space of A of m cross n. This is also m cross n, but we generalize it to n. So we consider m and n are equal. So O of n. Now, in the brute force, it was constant space, but in this, we take extra space. Okay, so I hope everyone understood the question. What was it about? If you have any doubt, if you are not able to understand how we are finding final position, after that, how we are finding the number of row in which it lies, or we are skipping the number of rows, and the number of columns which we need to skip, or in which it lies, do let me know. I'll help you guys with it. Thank you.